Thank you all for coming. We're going to spend the next 20 to 30 minutes talking about NFV and with a particular aim of focusing around the business realities that someone faces who's deploying today, not as a science project in their CTO's office, but based on the real world examples that our team has developed over the last 2 years with carriers worldwide who are deploying NFV into production. What are the business realities of that? What are the guidance that you need, and what are the concerns that carriers have, how to get around those in order to have successful deployments. So thank you all for coming. My name is Dave Wright. I work in VMware's telco NFV group. I drive operations for that team, and to date we have deployed over 45 different projects into production with carriers worldwide related to NFV. Ranging in size and scope from very small deployments of certain virtual functions all the way up to clouds running millions and millions of subscribers and containing over a dozen virtual functions in a common cloud. So for those of you who aren't familiar with NFV, NFV is all about virtualizing your core network and taking what was originally in a very physical form factor and putting it into a virtual form factor. So we'll talk a little about the business realities of this, and then in about a half hour or so, I'd like to bring on to the stage a few of our key partners who are also working with us to implement in this space to help give you additional guidance on what to do and what not to do around NFV. So with that, I think let's start with the basics. Why does a carrier feel it's important to implement NFV in a production environment today? The necessity of NFV really has less to do with cost than it does with agility at the end of the day. If you are a carrier who is used to pre-building infrastructure for demand that you may experience 6 months from now or a year from now, but you want to be sure that you have the capacity to meet that demand for a period of time, you're going to be overbuilt within your infrastructure. Similarly, if you miss time, the amount of capacity that you bring to the market, you may be underbuilt for an opportunity that emerges which requires capacity that you don't necessarily have. Now, this is a trickier issue than you might think, because it's not just about building out capacity for any particular function. It may be that you've built out proper capacity for one function that's necessary to deliver value to an end customer, but you're bottlenecking on another function. And so what's really required is a model that allows you to, in a vendor-independent way, in an agile way, match the pool of computing capacity that you have to the needs that you have in a much more agile fashion than you have done historically. And that's really at the core of what's valuable about what NFV does for you today. Over the course of the last 2 to 3 years, we've really found carriers focusing in 3 different areas of architecture as they deploy NFV, and looking at these 3 will give you a feel for the evolution that carriers who are putting NFV into production have gone through in looking at this space and deciding what makes sense and what doesn't make sense. The first incarnation of NFV in the industry, which has been around now for quite some time, is very simple. Think of it as an appliance model. You had a function that you were delivering in a physical way, and you have virtualized that function, put it into a hypervisor, run it on an x86 server. Are there benefits? Absolutely. Your hardware costs are lower, your management costs are lower, and you have a certain amount of flexibility, but the overall solution is still very tied to the application involved. It's not a broad solution if you want to put an entire array of cloud capabilities into your infrastructure. And so the next stage that most providers have adopted is one where they move to some or other portion of cloud, but they do it with a single vendor. In this scenario, you have multiple applications running in a single vendor environment managed through a single vendor solution. You get an integrated OEM solution from that vendor. You become very dependent on that one vendor for the integrated solution, but you do have the ability to deploy a number of different virtual functions that that particular vendor supports. Sometimes those functions are those that are only sold by that vendor. Sometimes a vendor will provide you with infrastructure that gives you the ability to run multiple VNFs from other vendors, but normally it's an all-enclosed solution. Now there's a lot of business value to this approach because you are mixing and matching more capacity. You're pooling more capacity into a single available resource for the use across of these virtual functions. So that area is where a lot of carriers are active today. But there's a next generation solution which more and more carriers are turning to and are starting to adopt today, which is a common platform solution. And this is where things really start to get interesting from an operator's point of view. In this scenario, the carrier is taking responsibility for the cloud environment they're deploying. And they are then picking the hardware vendors that they want to implement underneath that cloud, as well as the application and orchestration vendors that they want to implement above that cloud. Now, this is a new way of approaching virtual network functions and NFV infrastructure in general that some carriers are finding very powerful for a couple of reasons that we'll discuss. But ultimately, in this model, you get the widest array of flexibility because you're able to match any particular hardware infrastructure into a common pool of capability and then match any particular virtual network function into that same capability. So that has a lot of VNF vendor independence. It's multi-cloud and multi-domain. It's a modular platform, and you see more and more carriers adopting this model rather than just going with a single vendor solution. So ultimately, the goal here is to create an architecture for NFV that eliminates the silos and creates flexibility, that decreases the amount of dependence that you as an operator have on any one vendor in your ecosystem so that you have more leverage and more power, and to match supply with demand in a more flexible way across the applications that you deploy, as well as the infrastructure and capacity that you put in to enable that. So I'll give you some real world numbers, and this hopefully will help drive home the point that we're making, because these are all based on production deployments that we have done over the last 2 years with major carriers worldwide. If you look at the infrastructure savings from NFV as being comprised of 2 different characteristics, the savings one can get at any point in time from aggregating my hardware and my infrastructure costs, and then the savings that I get from agility in being able to mix and match capacity in real time to my problems. The custom stack and the common platform alternatives both radically outperform the appliance approach. In terms of management and maintenance and overall engineering, the operational costs, if you were simply to deploy virtual network functions as appliances within your infrastructure without integrating them and without a common platform, are significantly higher than if you use a custom stack or a common platform approach. So the total TCO really gets much more interesting if you're able to deploy multiple virtual functions on a common platform. So that's the major lesson that most carriers have learned who have deployed over the last 2 years. It's not about just virtualizing, it's about virtualizing multiple functions in a common cloud infrastructure. And looking at this slide, it might be tempting to conclude that there really is no added value for the common platform versus a custom stack. And I might look and I might say to myself, well, if my savings are substantial just going with an OEM solution without creating an independent platform that I have to manage myself, why would I ever go to that third phase that everyone is talking about in terms of common platform? And the reason you do that is that there is another layer of value associated with being agile in market that you get with the common platform approach that you don't get with the custom stack approach. So let me give you the second half of these numbers and you'll see what I mean. When you deploy NFV infrastructure, it's not just about saving money with a pooled amount of hardware capacity. What it is being able to change and rapidly apply infrastructure and capacity to new problems as they emerge in your business much faster than you could before. You can't be forced to anticipate what's going to happen 18 months from now and pre-build for that. You have to be able to take a common pool of infrastructure and apply those resources as needed across what turns out to be an unexpected or potentially unforeseeable array of capabilities. So for example, one carrier deployed voice over LTE and IMS. They found that was very valuable, but then suddenly needed to deploy voice over Wi-Fi in a particular environment. How fast could they get that additional capability up on the same infrastructure without any changes? If they had gone with an OEM-based solution and did not have access to the VNFs that they needed, they would have had to wait. But if they have a common platform approach, they can go to any vendor offering the voice over Wi-Fi solution that interests them, deploy it on that common infrastructure, and get to market faster. The value of that approach is quite significant. As you can see, with a common platform approach, what you're doing is you're breaking the cycle of cost that is typically in place in a telco between scaling up your complexity and scaling up your costs. As your complexity rises here, as your level of requirements rise, your costs do not follow them linearly. So as you get to scale with virtual functions, the common platform approach turns out to be much more compelling. And so when we have major carriers that are deploying 10 or 15 different types of VNFs on a common NFV infrastructure, whether that's IMS, voice over LTE, PCRF, HSS, virtual EPC, if you combine those and as the size of those clouds goes up, the costs do not track linearly, and it's very, very much more cost effective as you get larger, which is what carriers like to see in their infrastructure. So that's really ultimately why we recommend the common platform as an ultimate architecture. It gives you that flexibility as you scale up in both size and complexity. So I'll just give you one example of a customer that's deploying at this level of size. Our partners with IIJ at Internet Japan were kind enough to supply us with some results from the deployment that they currently have, and we'd like to showcase them for a minute. So I'm just going to give you guys a couple of minutes of video here showcasing what IIJ has done in Japan around their virtual CPE solution and how that's worked out for them in market.
IIJ provides internet connectivity services, network-related services, cloud services, systems construction, operation and maintenance services, and also development and sales of telecommunication equipment. Our market is not only in Japan, but extends internationally. Maintenance of servers as well as network equipment is getting ever so complex, involving tasks like patching vulnerabilities, keeping the equipment updated and so on. This means that owning network equipment and security devices on the customer's premises could put them at risk. That's why we've developed cloud-based services where the network functions are provided in the form of software. Our aim is to reduce the cost and risk caused by running ICT devices on the customer's premises. IIJ Omniverse Services is designed around the network processing system and offers various service modules. This generates a virtual network space dedicated to each customer where they can use functions including internet connection, firewall, WAN, cloud connection, and more on demand. What's unique about our service is the variety of network capabilities that we offer. We selected VMware's vCloud NFV platform to support our services because it met our requirements to support multiple virtual network functions and has been proven in a real running environment. vCloud NFV provides IIJ with a stable and trusted network functions virtualization platform. Our services manage and control software and bring flexibility to the customer's systems. This helps to reduce the customer's operational costs and also overall cost by using resources efficiently. With NPS Gateway at the core of our services, we plan to extend the IIJ Omniverse services worldwide by making the most of SDN and network functions virtualization capabilities. In future, we hope to link SDN technology to customers' LANs to enable fully centralized management. We are determined to lead the SDN and NFV market with our IIJ Omnibus services.
Excellent. And I think one of the key messages that I would love to drive home with you around what IIJ has done in Japan, as well as some of our major carrier partners have done in the mobile core, is the point that the economics of NFV, particularly the economics of a multi-service, multi-vendor, common platform approach to NFV hold regardless of the use case area that you're working in. So IIJ was focused on enterprise-facing use cases, layer 4 through 7 services that add value to a CIO's enterprise network and his capabilities, and providing those in a value-added way. Similarly, a partner of ours like Vodafone or Ooredoo is working in the mobile core. They also have a multi-vendor approach, but those capabilities are buried in their network core. IMS, voice over LTE, etc. The point is the economics associated with the value of being able to be agile at scale are the same whether you're facing the enterprise or whether you're facing the mobile core. And that's one of the powerful things about NFV. So I'm going to add an additional layer to this for those in the audience who are more familiar with NFV architectures and who understand the fact that VNFs, the virtual network functions that are being deployed, are in a state of constant evolution and advancement. To make a second point about what our carrier partners and our customers have learned over the last 2 years that's important if you're going to be successful with NFV. When NFV first emerged onto the market, there were a number of VNF providers who took their applications from physical, moved them and just dropped them right into hypervisors and ran them in that environment. If I'm an application that's used to running on physical and you drop me into a hypervisor, I don't know that I'm in a hypervisor. I expect the same quality of service, the same resiliency, the same high availability that I had on physical. The container environment that I provide needs to reflect those realities and has to offer that same high availability. However, if I'm an application provider, for example, say Affirm Networks or someone else that's a sort of a next generation VNF provider where they've written their application from the start to expect to be running in a cloud, they may take responsibility for certain functions that the hardware used to do, like high availability or security or something like that. Their environment can exist comfortably in a different kind of a container, say OpenStack or some other manner. Similarly, in 4 to 5 years, many VNF providers are going to expect to see a container environment, Docker or some other environment, be the primary area that the primary container environment that they utilize. If you are a carrier, how do you keep up with all of this? The answer is you have to have an architecture where the management environment that you are able to support is able to handle any type of application architecture. So what we do with VMware's vCloud NFV platform is we support multiple virtualized infrastructure management solutions. If you have a cloud-ported VNF, you can run and use our vCloud Director VNF Manager. It has all the high availability constructs. It acts as if you were running on physical. It gives you the ability to maintain those expectations. If you have a cloud-first VNF that wants to run on OpenStack, we have VMware Integrated OpenStack, which provides a solution for that environment. And in a year or so, we will have both VMware Integrated Containers and Photon as solutions for our platform, which will allow you to run directly in containers. So the key important point here is future-proof your platform to begin with by implementing an architecture where you can mix and match the virtual infrastructure management layer and not remain completely dedicated to one particular way. Otherwise, you're radically limiting the alternatives that are available to you in the area of which VNFs you can actually run. So real quickly, for those who aren't familiar with VMware's platform, this is what gets deployed. It's called the there's a misspelling on the side, but it's not vCloud NFV, it's vCloud NFV. But it's a common NFVI platform for multi-vendor NFV deployments. I'll give you a little more detail on the stack maybe during our discussion, but think of it as a way to implement any type of VNF of any kind on a common platform with virtualized network, storage, and compute in one integrated package. That's what we sell. We partner all over the world with VNF providers who run on this platform. Over 60 different VNFs are compatible across about 30 different providers. So it's been battle tested. We have a lot of production solutions and a lot of learnings as a result of that. And at this point, I think I'm going to leave you with the notion that NFV is a work in progress, and the carriers who are deploying it are achieving real value today if they hold to certain basic tenets for success. The first basic tenet I talked about was the need to focus on a common pool of resources across multiple solutions, multiple VNFs, that allows you to be agile in how and when you deploy these capabilities into market. The second advantage I mentioned was the common platform architecture, which focuses on the carrier taking responsibility for its own cloud rather than leaving its entire fate up to in the hands of a particular OEM partner. And then the third is future-proofing that deployment by supporting multiple virtual infrastructure management environments rather than just one, say OpenStack or containers or any proprietary solutions there. So with that, I think I'm going to stop and invite a set of partners up onto stage who've had real-world experience implementing their VNFs and their solutions on our platform, and we can have a little discussion to help you guys understand exactly how this works in the real world. So Martin from Metaswitch, would you like to come up? And the folks from VeloCloud, please, and Sienna, and Erickson, and Affirm Networks. So why don't we start by giving the audience a little introduction here. Why don't each of you tell us who you are and who you represent and what type of offerings you provide in market.
Sure. So I'm Martin Taylor. I'm Chief Technical Officer at Metaswitch Networks. We have a portfolio of VNFs around the IMS space. So the CSCF, session border controllers, gateway controllers, telephony application servers, essentially a complete virtualized IMS solution. We have a whole bunch of virtualized deployments running on VMware, upwards of 30 or so. So, you know, this is real. We've been in production on VMware for about 18 months now, I think our first tier one deployment. So, you know, this is kind of becoming routine for us now.
Very good. Let's pass that down.
So my name is Ray Wang. I'm a solution architect in VeloCloud Networks. So our company actually is a cloud-delivered SD-WAN company. In our company, we are actually, we became a VMware tab partner in 2015. We are actually working with about 6 of the top 12 network service providers. Most of them are actually looking at delivering the SD-WAN solution in an NFV environment. Actually, one of the service providers we just have a press release today is Medtel. It's a service providers in the East Coast in US. They're actually running our service, which is our gateway, in a VMware NFV, vCloud NFV platform. So, yeah, thank you.
Thank you. Sienna?
Hi, thank you, everybody. My name is Recep Ozdag. I'm responsible for our Blue Planet SDN NFV orchestration platform. So we don't provide any of the virtual network functions, but we're responsible for the orchestration as well as the lifecycle management. Sienna has quite a bit of an established customer base, and what we're seeing is a lot of our customers, the first use case is the virtual CPE, as you mentioned, particularly on the managed services. So lowering CapEx, OpEx are useful, but also a lot of the network operators are able to quickly offer managed services, so managed virtual firewall, virtual router services very quickly, and we're seeing quite a bit of success, particularly with the VMware platform.
My name's Jeff Hollingworth. I work for a company called Erickson. We're probably, hopefully, familiar with Erickson. If I sum up what Erickson does for this audience, we industrialize to scale solutions around the world. And I think growing on this conversation, what we're seeing is the introduction of everything being software defined. Now that introduces a lot of flexibility, agility, and benefits. We now need to industrialize that to make sure it works when it needs to work and it works with the right efficiencies and performance. We do many engagements in over 180 countries. We have engagements with VMware in many places. We pre-certify with VMware to de-risk situations, and we can go into more details about that.
My name is Amit Tiwari. I'm Vice President of Strategic Alliances and Systems Engineering at Firm Networks. We've been working with VMware for a while now. We are one of those ISVs who provide core native cloud-based software. We have about 35 commercial deployments now, and something we are very proud of is we have a tier 1 deployment in pretty much every major geography. Most of them, like Dave was talking about, are actually on VMware. We actually announced our Vodafone deployment today. We've been working very closely with VMware, and if you look at our approach to transformation of these networks, it's very much NFV first. We were born in the age of virtualization, and that's where we wrote our software for. So we offer a complete set of VNFs in the EPC space, in the GI services space, for secure networking, as in an EPDG and a TVAC, TVAP for Wi-Fi access. So think about us as a cloud-native software provider for all access for mobile networks.
Well, thank you, gentlemen. I think this is going to be an interesting conversation. So, I think one of the interesting things I didn't touch on in my talk was the fact that one can use software platforms to create multi-service, multi-tenancy, but one can also do it in the hardware. And so why don't we start first with the gentleman from Erickson, and let's see what does it mean to be successful with NFV when you're coming at it from the hardware side, in addition to coming at it from the software side?
Yeah, no. So one of the large items we're introducing and accelerating at this show is the concept of software-defined infrastructure. So there's a very interesting TCO charts I saw there where with a common stack, then the cost structure comes to about 2/3 CapEx to 1/3 OpEx. We want to take the CapEx out as well. And what that really means is implementing the same approaches to software-defined infrastructure that the hyperscale giant providers have done. What that means is orchestrating at component level, on the fly, software-defined machines at bare metal that then can automatically deploy VMware on top, kind of like instantiate, disappear, and then the utilization and the actual lifetime management of that hardware becomes software-defined as well. So we don't see anything staying the same in terms of delivering infrastructure that has to scale to meet all the connected devices that we currently see connecting.
Very good. And actually, let me flip it all the way to the top of the stack and ask the gentleman from Siena about service orchestration, because one of the key things that we find is that it's one thing to be able to flexibly deploy VNFs and maybe multiple VNFs on a common infrastructure, but you don't get the full value out of the solution if they are not well integrated into common motions with respect to lifecycle management and with respect to service chaining. So let's hear a little bit about the value add there.
Yeah. So if you think about orchestration, what it really tries to do is bring SDN and NFV together. So not only is it, for example, deploying the virtual functions such as virtual EPC on a VMware cloud, but also you're traversing the wide area network. If you think about the wide area network, it consists of a multi-network, multi-vendor deployment of network devices. So not only do you control the underlay, talk to all these devices, and provision a line from the data center all the way to the customer. And by the way, if it's a virtual EPC, maybe it's from a data center to a E node B. But if it's a managed service, it can be going from a data center to a virtual CPE device. But what we, again, find very interesting is that we want to be able to focus on the service, create programmable services, and not have to worry about the infrastructure. So high availability, resiliency, failover, being able to identify faults. We're glad that actually VMware provides a complete solution with world-class support so that we don't actually have to do those from scratch. We can actually just call the APIs that are field-proven, right? And so that's why we see the value both coming from the VMware side as well as the orchestration, as well as the functions.
Excellent. So we've heard a little about, you've heard a little about from me about the flexibility of multi-service, multi-vendor. We've heard a little about how hardware can enable that in terms of the level of flexibility that you can have if it's essentially a cloud-aware infrastructure underneath, as well as what service orchestration can do up above. But let's focus in on the application layer for a minute. Martin and Amit, you both sell a number of functions into this space. You both have a number of successful commercial deployments at this point. What, if you had to do 2 or 3 things to give our audience as best practices or things to try to do or not do, what would they be? Martin?
Sure. So there's a class of applications that are relatively undemanding in terms of underlying infrastructure, and they make for good low-hanging fruit when you look thinking about what to virtualize first. So IMS as a class of applications doesn't require SDN and can be deployed without a lot of heavyweight orchestration. So it is something that you can treat, more or less as something that you
test case.
Yeah, as something you can deploy on a VMware environment, very much like you would deploy an IT workload. Now, there are certainly things that you have to pay attention to around high availability and to some degree around packet throughput performance. We can address high availability by spreading our VNFs across multiple cloud instances so that we can deliver a 5 nines available service from a 3 nines available cloud. And we can address the packet performance issues by configuring the applications to make use of SRIOV, which VMware happily supports. This is a really good place to get started with virtualization. And you don't have to wait until you've solved all of the problems about how you're going to build your software-defined network pieces. You don't have to worry initially about orchestration because you can perform the lifecycle management operations manually. It's not particularly demanding. And then you can come and retrofit orchestration once you understand what the value proposition is for that. That's the basis really of all of our deployments. People coming at this with a basic understanding of VMware, deploying as if they were deploying IT-style applications, paying attention to those 1 or 2 things that you need to get right, and worrying about automating a little bit further down the track.
So starting with the right application workloads, focusing on control plane and other workloads that virtualize well, that may be easier to manage as a test case to make sure that you know how to operationalize your NFV implementation, a good advantage. Let's move on to Amit. You have a more demanding application in virtual EPC.
Thanks, Dave. I was going to say Martin covered one end of the spectrum, I'll cover the other. If you look at a firm and an EPC, we're talking about a very complex set of VNFs, in some cases very high payload, right? Having deployed now a bunch of these networks now, several running multi-million live subscribers, actually, a couple running, north of 10 million. One of the things that we see that's so important for those operators who can scale up quickly is look at the newer high growth applications or use cases that actually look at the next generation or the areas that are rapidly growing rather than actually try to do a point for point, feature for feature comparison for the legacy work, right? Because you can imagine there is devices and there's workloads out there that span the last 20 years of mobility. If we try to do a match for those, we can spend an inordinate amount of time trying to do feature parity and get to basically a baseline, and that baseline is a ground level, right? So the operators that we see moving very fast and scaling up very fast are those who look at next generation. It's even more relevant now, when we talk about the microservice concept with 5G and decomposed architectures. Look at the next generation of services that have a steep adoption curve. Look at those capabilities and features and adapt and deploy those faster with a low-hanging, to what Recep and Martin said, low-hanging orchestration requirements, right? Because see, that's one area that's still catching up, right? You can see VNFs, that very well defined, very well decomposed, virtualized, leveraging all of the VMware tool characters out there. Look at lightweight orchestration requirements, then work very closely with folks like Recep and the Sienna orchestration platform as we do deeper and deeper integration. But to deploy today, look for next generation, newer microservice-based use cases, orchestrate lightweight, and then look for deeper integration into strong orchestration capabilities. That's what helps scale very fast.
Very sound guidance. Let's look out ahead a little bit. I gave you guys a taste of where we're going to go, VMware, as a product platform company towards VMware integrated container capabilities, as well as Photon, our next generation container-based platform. I'll just briefly describe those two because they're coming in the next couple of years. We'll have our first launches of those products later this year. But think of VMware integrated containers as the ability to create micro VMs, each of which constitutes a single container, and then manage those as if you would manage a regular VM. You can vMotion them, you can pull them up and down, they can have anti-affinity settings. Anything you can do with a VM, you could do with a container. So it hardens the container model and makes it suitable for anything that today could potentially run in a virtual machine, except it uses the container construct. So a VNF that's writing to a portability model could write to Docker, but know that they could run with the characteristics of a full production virtual infrastructure like vCloud NFV. Photon, on the other hand, is a next generation model that is more like a public cloud model with microservice-based architectures in mind. That will be for next generation applications that we haven't even yet seen to market. You're starting to see this with the BSS providers who are going into the cloud and turning their apps into SaaS applications. It might be microservice based, but to date, VNFs are not yet there yet. So look on that as the next 2, 3, 4 years as VNF providers evolve. You're going to start to see the need for container environments managed through Mesosphere and other types of environments predominate as well. But let's throw it back to our panel. Gentlemen, I'll just ask each of you briefly to give us your thoughts on where do you think NFV is going over the next 2 or 3 years, and how does your company plan to play a role in that?
Absolutely agree that that trajectory you showed towards cloud native is the way to go. Some of us are already there. The Metaswitch IMS core is microservices architected. It's scale out. It's cloud native. It's designed to be bulletproof across a geographic redundant setup. Stateless transaction processing, separate state stores. That whole modern architecture. And it is compatible with containers. We've actually shown the Clearwater core running in Docker. It's even less demanding on the cloud, if you like, than some of these other earlier generations of technology. It doesn't really mind whether there is no vMotion or there is no HA, or it's designed to be to keep running, whatever happens underneath. That's really the message here. So we've got some kind of older generation VNFs that will, they're absolutely cloud ready, but they'll take a little bit of time to catch up with that full web scale thing. But that is definitely the future, no question.
And how does VeloCloud fit into that future?
Yeah, so I think, so traditionally, if you look at networking, right, VeloCloud being a networking company, traditionally when you look at networking, your customer is more used to having boxes, having giant box in the network. VeloCloud, I think, like from the get-go, we really try to build a true software-defined infrastructure. So all three of our components, being the edge, like the CPE device, can be run as a VNF on the VMware vCloud NFV platform, commercial off-the-shelf platform. We also have a x86-based appliance with specific interfaces that we can run on. But the idea is it can be run on any x86-based platform, right? And then the next layer, we have the gateway, which is actually the termination point of all our edges. Again, it's actually a software that can be run on VMware NFV platform. And finally, we have a SDN controller. Our Orchestrator, once again, is a software, a cloud-based software that is right now just running on in the internet. So what we see is really we want to provide a solution to all the enterprise, to all the service providers out there, right? A true software-defined next-generation network.
Right. Thank you, Ray. I think service orchestrators see probably a wider swath of the entire industry than anybody else, so you're well positioned to talk about the future, I hope.
Yeah. So interestingly, last year we announced Blue Planet 2.0, which is our orchestrator, which also was re-architected to be based on microservices as well as containers. Now, working with a number of NFV or VNF vendors, because we don't provide any of the VNS, or we just provide the orchestration, we're seeing, you know, a wide spectrum, right? There are still those who just give us an ISO image and say, can you orchestrate this, which we can, but then there's also the, you know, those NFV vendors or VNF vendors that are actually using web scale technologies. And by the way, when you say web scale, yes, microservices, containers, this is not really a new concept. It's just a new concept applied to networking therefore, anybody who's using microservices and containers, we can add them to our orchestrator, and there's less work that we have to do. This means that less work for the operator to do, because it already has the foundation to easily scale, easily update, easily make changes. By the way, making changes is one of the advantages also of microservices, because there are new features rolled out all the time. And if you look at NFV, it's really the concept of bringing IT-type agility to the networks. But if you look at IT, what do the Googles and Facebooks of the world do? They introduce new features, services all the time. And that's what we're really trying to do with the microservices. Rather than have this one monolithic application, you have all these microservices together working to deliver a solution so that we can quickly, easily change them and add new services. But you know, there's definitely leaders in this area, and then there's other VNF vendors coming in slowly. And I think it will still take them a couple of years. One thing that I would add is that I think, you know, 2016 is, as you know, with the announcements, operators are now saying, yes, we're starting to deploy NFV. Personally, I'm seeing more on the virtual CPE side, because there's a lot of, you know, you can apply for greenfield applications as operators are expanding to new businesses. Virtual EPC has always been, in my mind, a bit more slow because it's a core service, but definitely I know that Affirmed has been in this area for a very long time. But you know, I think 2016 is finally the year that we're going to see more and more announcements. Yeah. I would still say that, you know, it's still a couple of years away until we see the majority of them being deployed. But that's my observations.
Thank you. So Erickson probably has more history in telecommunications than any other vendor in this space, and certainly one of the longest range views of how this industry will evolve over time. All the way through 5G. What are your takes on where NFV is going and where NFV platforms in general are headed?
Yeah, we don't see business as usual going forward here. We're going to go through a large transformation as an industry. So what is important to service providers that we care about and drive forward? Simplification. It's got to be simple. Now, simple is got a few different ways around that. Simple is something that you're used to, and it's something that's easy to use. We like working with industry leaders because people are familiar with how this works and they're on a path of actually increasing the capabilities. There has to be a de-risking and a scale in deploying all of these services, and we don't see speed slowing down. We see speed increasing. And what we do see is the balance between speed and risk. So as you go faster, how can you go faster without endangering actually the core principles of your business as you move to being a software-defined company? Because the architects of the future are software developers. We should understand the people who are going to build the world that our children live in is going to be designed by software developers. Software developers don't wake up in the morning and get excited about industrializing, securing, having strong governance. So we have to start enabling those capabilities in a platform. And that enables speed without risk. And you do that by having explicit policy control, explicit governance, to a scale that even we find hard to imagine now. As you move to connecting billions of devices, every car is connected. You need to know where those cars are going, how they are connected, who put software in them, where the data has come from, going from, and have a chain of attribution to that, so that then you can have the confidence to actually innovate and lead a market rather than being worried every morning that you're going to get disrupted by it.
Excellent. Amit, some words from the world of virtual EPC.
Absolutely. So, looking forward, we see there is a few major trends and major drivers that, at first glance appear to pull you in different directions. And I'd like to share that with you. One thing that we see is, if you look at NFV as it stands today, it brings to the operators the benefits of IT-type deployments. Raw compute, being able to dynamically transform workloads over to this raw compute model, being way more efficient than they are today in terms of compute. One of the challenges that they still observe, we see this in the networks even we have deployed, the flexibility and the velocity of launching new services. Because it goes back to one of the comments that you made earlier. Operators deploy things with strong governance. They have a requirement for service assurance. They have a requirement for strong KPIs. Those all don't go away. The environment gets more complex, more diverse, it's way more varied, but the governance, the KPIs, the service assurance, all that stays, right? So on the one side, you have to maintain all of that, scale that to a web scale model that's exponentially more diverse and more spread out, but keep maintaining the level of service assurance that you had before. So one of the things that we want to leverage to the market where, being cloud-born, what we are able to do, if you look at our architecture, we have decomposed our architecture from the get-go. This was prior to the 5G discussion. We leveraged the most out of the VMware tool set that we could get, and we leveraged that to actually make sure we are totally decomposed, even within the VNFs that we actually pull together. So one of the trends, the other side of this that we observe that we think will be very critical for the next generation is the decomposition is an enabler for what we do today. Being intelligently able to recompose those functions into dynamic personalities towards the service assurance for new services is going to be key, right? Because rather than carry the baggage of these monolithic, backward-looking applications that are now running on raw compute, that's one approach. The other is totally decomposed architectures, but then actually recompose them for, think about this, connected car for telematics, the set of requirements is very different than connected car streaming video to the backseat to the kids. Right? There's a completely different set of use cases within what appears to be one use case. Now, if you are completely decomposed and you recompose your functions to address these diverse use cases, I just gave you one example, right? IoT, we talk about so many use cases, from power meters all the way to HD transmission of health data. Think about the diversity in these two use cases. They're both under, under IoT. So having a truly decomposed architecture, we believe, is a raw material for this. Then actually being able to intelligently recompose and orchestrate, back to that discussion, is what enables the next generation at the web scale, massive scale, that's going to be required when you connect everything.
Right. Thank you very much, Amit. Well, I think hopefully over the last hour, you've heard some of the history and the war stories and the best practices of how to implement NFV in the world today, in the wild, based on real-world production infrastructure, some of the rules to follow in getting the most out of that infrastructure. And thanks to a panel of basically pioneers in this space, you've learned a little bit about some of the ways in which various types of vendors are participating in this, and also a little about the future of the space. I'd like to thank our panel very much for participating. I appreciate your attendance, folks, and that'll be it for us. Thank you very much.